There is grandeur in this view of life.
I read a lot, and sometimes too much, if it's really possible to read too much. My interests range from evolution to philosophy to music, and sometimes these interests overlap, and more often than not, they'll take me into areas that I didn't expect them to. Like philosophy, for example. I love reading about the idea of free will and whether or not we have it. There are thought experiments that suggest we don't have the freedom of will that we think we do. Then there are those arguments to attempt to explain free will by invoking the mysterious world of quantum physics. The quantum world is a strange place where strange things happen, and one of these is a concept called superposition. Basically, it states that a subatomic particle like, say, a photon, exists in many states at once. And if we were to single out this photon for an experiment, the outcomes of that experiment are all present simultaneously as if they were layered upon one another. Commit what I just said about being layered upon one another to memory for just a little bit. This layering, as far as superposition in quantum mechanics, is called a wave function. When we perform the experiment and look to see the outcome, all of those layers condense into a single layer. The wave function itself collapses. Before we observed it, all outcomes were possible. Like I said, that's extremely strange, and it is hard to wrap one's mind around. Now that is the concept of superposition, that all of those layers were superimposed upon one another, waiting for an observer to observe them. Now when I first came across the concept, it sounded awfully familiar, especially the ideas of layers waiting to be observed. And then it hit me. When it comes to the study of evolution, we often rely on another set of layers to help us understand the sequence of events an evolutionary path is taken. It's also called superposition, and it has nothing at all to do with the quantum realm. Let me explain. To understand this, we must first travel back to the region of Tuscany in 1666. It was then that a large shark was caught off the coast of Livorno. It was such an impressive size that its head was cut off and sent to Nicholas Steno. Steno was a Dutch scientist who had an interest in both biology and geology, and it's lucky for us he did. When he dissected the shark's head, he marveled at the size and shape of its teeth. He'd seen something similar before. They resembled what was known at the time as tongue stones. Now, these stones resembled teeth or other biological objects, and the prevailing thought was that they grew in the stones and the rocks that covered the land. After all, they were embedded in the ground in layers of rock. How else would they have gotten there? Steno didn't exactly believe this. He wanted to understand how an object that resembled shark teeth could ever be found in another solid object, like a layer of rock. In his 1669 book, Dissertationis Protemus, Steno laid out his idea of superposition. And this ultimately gave birth to the sciences of stratigraphy and geochronology, the study of rock layers. Imagine I had 4 people over for a pancake breakfast and everyone asked for a different pancake. There's a request for a blueberry pancake, a strawberry one that's basically plain, and one that has chocolate chips in it. When I bring the stack to the table, it would be pretty easy to tell which one I made first. It's the one at the bottom, right? As I made them, I stacked them. The chocolate pancake at the top was the one I made last. It's the most recently cooked pancake. And that was what Nicholas Steno laid out with his law of superposition. And no, it had nothing to do with pancakes, but it did have everything to do with the layers of rock beneath our feet. Those layers tell a story. The deeper the layer, the older it is. As we get closer to the surface, the ground that we walk upon being the most recent layer, we are standing on the present. And remember earlier, I asked you to remember the concept of layers. That idea from quantum mechanics that all possibilities are superimposed upon one another, waiting for an observer. It's not so much different here. A sequence of sedimentary rock layers all stacked upon one another in superposition, waiting for an observer to interpret the tale that they have to tell. What Steno sought to understand was how those layers became rocks and how objects like fossilized teeth found their way into those layers. Steno surmised that the layers closer to the surface were formed more recently, on top of the older layers. It makes sense. A tooth found in a deeper layer would be older than one found at a layer closer to a more recent layer. Steno's law of superposition changed everything. Understanding how layers are formed and what they contain is not unlike having a naturally formed history book, each layer being a page from a different time. For example, let's say that we were standing in front of the face of a rocky cliff, one that has been eroded over the years. If you look closely, you can see all of the different layers. Some are slightly discolored, maybe a flood occurred or a spate of volcanic activity. And if we step closer, we may see what appears to be a fossilized shell embedded in the layer that's at eye level. At the layer level would say our knees, we see what could be a bone. It's just difficult to tell what kind of bone it is. But from our studies, we also know that by the composition and appearance of that layer, that it was formed by what was once molten rock. We can safely say that the bone is older than the fossilized shell because of the sequence of layers. But there's a catch. This only works if the layers haven't been disturbed. If the layers are mixed up, it can be tricky to tell which is older or which is the oldest just by its position. So, when geologists and archaeologists find a place where the layers are as they should be, it's like hitting a jackpot because they can read the Earth's history book from those layers. But how do they get mixed up? What could jumble up those rocky layers that are our pages to make it difficult for us to piece them back together again? Well, let's look at a few possible culprits. Erosion is one. It can create what is called unconformities by wearing away older layers. These are missing pages in our history book. An ancient landslide could do something similar, taking a bunch of pages, ripping them out, and mixing them back together into a narrative that really makes no sense. Other natural disasters, such as earthquakes or volcanic activity, can also disrupt those layers. Given that the law of superposition tells us that the layers nearer the top are younger than the deeper layers, it can be incredibly frustrating for, say, a geologist or archaeologist to interpret the story when the pages themselves have been shuffled. We can even be our own worst enemy in these situations by digging into these layers ourselves to understand what they were trying to tell us. We might inadvertently mix the pages up by doing so. And when these kind of disturbances happen, geologists have to play detective, using clues from undisturbed areas or relying on other dating methods to piece together the history of the area. The world is, as I've said a billion times over the course of this show, a very strange place. From the smallest of particles in the quantum realm to the largest rocks in our physical realm, there are stories to be found and also understood. But the exciting of Evolution Talk. I'm Rick Host, and if you find value in the show, please consider becoming a patron at evolutiontalk.com/support. I've also mentioned that there is a YouTube channel now which you can subscribe to. I'm trying to put out videos for that channel maybe once a month, and they are going to be slightly longer form moving forward. And I'll put links in the show notes. So please spread the word and share the show with your friends, with classmates, and also teachers. At evolutiontalk.com, you'll also find more information, some recommended books, and ways to contact me. I'd love to hear from you. And I hope your week's going well, and until next time, please take care of yourself.